In order for sexual reproduction to be successful, the cycle of egg development and release must be coordinated with the preparation of the uterus for possible pregnancy in a woman's body. A series of hormonal interactions accomplishes this coordination of the ovarian and menstrual cycles. Through these cycles, we will follow the activity of 5 hormones: gonadotropin-releasing hormone, GnRH, from the hypothalamus, luteinizing hormone, LH, and follicle-stimulating hormone, FSH, from the pituitary, and estrogen and progesterone from the ovaries. Roughly every 28 days, GnRH released by the hypothalamus results in the release of FSH and LH from the pituitary. These hormones, in turn, bring about changes in the ovaries. Specifically, a follicle, a single egg cell surrounded by many supporting cells, is stimulated by FSH to progress in its development. As it develops, the follicle begins to release estrogen, which results in further changes within the female reproductive tract. First, estrogen has a negative feedback effect on the pituitary, slowing its release of FSH and LH. Second, estrogen impacts the uterus by stimulating thickening and increased vascularization of the uterine lining, thus beginning its preparation for potential embryo implantation as an egg is prepared in the ovaries. As the follicle continues to develop, estrogen levels will continue to rise. This dramatic increase in estrogen changes its interaction with the hypothalamus, resulting in increased release of GnRH and a subsequently rapid rise in LH and FSH release from the pituitary. The rise of these gonadotropins, and LH in particular, stimulates the developing follicle to release an egg from the ovary, an event known as ovulation. Following ovulation, the remaining ovarian follicular tissue where the egg developed becomes known as the corpus luteum, a structure developed and maintained by LH. The corpus luteum in turn produces large amounts of estrogen and progesterone. In the uterus, these hormones facilitate the secretory phase of uterine lining development, characterized by further thickening of the uterine lining and secretion of a glycogen-rich fluid which can provide nourishment for an early embryo. Thus, as an egg is released into the female reproductive tract and made available for fertilization, the uterus becomes fully equipped to house the potential embryo. However, in a classic example of negative feedback, the estrogen and progesterone produced by the corpus luteum have an inhibitory effect on the pituitary and the hypothalamus, thus shutting down production of FSH and LH, the very hormones that maintained the corpus luteum. As the corpus luteum disintegrates, levels of estrogen and progesterone precipitously fall. As a result, the uterine lining is no longer supported and is subsequently shed. This shedding of the uterine lining marks menstruation. In the case of pregnancy, this shedding is prevented by continuously high levels of estrogen and progesterone, maintained by hormonal signals from the developing embryo and the placenta that supports it. However, in the absence of fertilization and embryo formation, falling levels of estrogen and progesterone results in the removal of hypothalamus and pituitary inhibition. As a result, production of FSH and LH begins to rise, enabling the initiation of another round of follicular development and the start of yet another monthly cycle. Hormonal control of the ovarian and menstrual cycles allows for precise coordination of these two complex processes and ensures that any potential embryo will have the highest possible opportunity for developmental success.